So you want any table or something? Shall I put on the table?
Keep it here only. You can sit here.
They told us some lobbies that they will be.
No, here only we
No, you want 3 phases.
3 feet back on. 3 feet back. Not required.
But if 3 phases is not required, we can keep it here. It's no problem.
We'll do it here only. Yeah. No, we'll connect it to this one only.
So if possible, you can connect the projector so that everyone can see. Or if you want to go separate the lamp also, we can. I'll share. Yeah. Possibly can share. Sorry, can you set the size of our cord is here?
Yeah.
This was this Five, six. How much is for the 5 versus 6. From here to here.
It's positive, negative. Understood.
The number to each is make it wrong and
Which one?
this will become here.
So it's square one. This way.
projectors.
Yeah. Limits and then we can.
Internet as well.
Have to make some
Settings here.
afterwards. I will come.
ಆಮೇಲೆ
Everything connected.
Here for is not connected.
Then will come. Side promoting there, man, you can just this 9 is the number. Game level.
Finished.
Ajit, वो लगा मित्र लगा अब मित्र लगा
ಇದೆಲ್ಲ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಇದನ್ನು ಆ ಕಡೆಯಿಂದ ಇಟ್ಕೋಬೇಕು. ಸ್ವಲ್ಪ ಅಲ್ಲಿ ಸ್ಪೇಸ್ ಮಾಡಿ ಇಲ್ಲಿ ಅಷ್ಟೇ.
చేస్తున్నాను ఈడ సరే సార్ నేను ఇది సెమినార్లో ఉంటా చేస్తున్నాను. After I finish, you sit here. Okay. Now it is not required. Your laptop, we can keep it here.
I mean, my screen only will present. My laptop.
No. Once I finish, I'll remove my laptop, then you can connect your laptop.
Okay. Done.
Correct. In that settings, you can turn this It should be more practically when sit it so that I can see on the screen. So this start.
So very good morning to all of you for this 1 week faculty development program. So today, day 4, session 7 will be taken by Prashant Kumar M on the title Substation Automation System Demystified, Components, Communication and Control. Earlier, Sir has worked as a project manager at QSoft Systems and Solutions, Oracle certified company. And Sir has also developed their own ERP and provided application server and database administration in Oracle. Later, they have started a substation automation company in 2011 using G Solutions. Afterwards, Sir has made the entire operation more competitive in substation automation at iGrid India. And they have also implemented 180 plus substation automation solutions across India. Now may I kindly invite the head of the department, Dr. Prem Kumar, to hand over this sapling as a welcome gesture to our speaker.
Good morning, everybody. Myself, my name is Prashant, and I represent iGrid India. We are into substation automation. Okay, and we have our own automation software called iControl Scanner, and we have our own gateways and RTOs which we use for our substation. What I am going to do is we are going to understand how the automation takes place in a substation. So this, as it is, we are doing it for the electrical department. What we got is we wanted to tell about more about how the activities are carried out in a substation. Okay. Now, when we talk about substation automation, we have there are different ways in which we carry out the substation automation. And so I am going to explain about the architecture, how the substation automation is carried out, and then there are different types of automation we can do. That is, we can do it using a brake control unit, and we can do the automation using what is called as an RTU, and we have other thing called as ADLS. Okay, RTU means remote terminal unit, and substation architecture means automatic data logging system. Okay, so we will understand different architectures and go through each of those components, and after that what we are going to do is using the relays and the meters, we are going to see how the data communication happens, and we can see a live demo of that. So when we talk about a substation, okay, usually what we do, there are different types of substations. So there is a generation substation, there is a transmission substation, and there is a distribution substation. Okay, so the solutions what we give, we call what is called as there are both hardware and software. Okay. Now, for example, whenever I want to do any automation for that matter, I need this SCADA software. This SCADA is nothing but supervisory, control and data acquisition. Okay. Now, what we do is we basically capture the data of the entire substation. So when I talk about so this what we are seeing is, for example, this is a one typical substation. Where here you can see that, so here if you observe, we have this a transmission substation where we have stepping it down from 132 kV to 33 kV. So this is a transmission substation. If I have to automate this substation, what are all the things I have to do? Now if you observe here, this side is called as a 132 kV side substation. Okay, this is a 132 kV substation. Here we have, for example, we have a 132 kV feeders and 132 kV transformers. Okay, so whenever I take a particular bay, nowadays, for example, if it is a feeder, we have what is called as a BCU. BCU means bay control unit. Okay, through using a bay control unit, what we do is we try to do the control operation of a switchgear equipment. Okay, control operation of a switchgear equipment, and we have this relays like the production relays. Again, when I talk about, if I talk about a incoming line, it is called as a feeder. In that incoming lines, we have like a distribution, like D60, that is distance production relays. Okay, using distance production relays, we do the production for the feeder base. So if all these devices are connected to a SAS panel, now in the SAS panel we have the gateways as well as the GPS.
Because of the city
Yeah. Okay, not required. I will show it to the user. What I wanted to do is I just wanted to understand. See, the thing is, all are from basically from electrical background, right? Okay. So you can feel free to ask the questions wherever it is required, so that I can make it more interactive. Okay. So what I was trying to tell is, see, when I am going to do the automation for that, what I do is we have main thing is we have control and relay panels. This control and relay panels will be having my protection relays. So this protection relays, I select the relays based on the requirement of the particular day. Say for example, if it is an incoming line, what we call it as a feeder panel. In the feeder panel, we give what is called as a distance protection, because the line is going to come from a generation plant to the substation. Okay, there the distance protection relay is kept. In addition to that, we also have the other protection schemes like overcurrent upfault relay. The different relays will be there. Now all these relays are communicable. Okay. Now when I talk about the communication in turn, all these relays communicates in IEC 61850. IEC 61850 is the protocol through which I can read the data from the relays. Okay. Now all these relays have got an IP address. Okay. What we do is we set up an IP address for all these devices, and to these devices, all these things are connected in the network to an Ethernet switch. Okay. So based on the requirement, so for example, we have two feeders there. Okay. We have two feeders here, and we have one bus coupler panel, and we have one transformer panel. Okay. Now all these things are then finally connected to the Ethernet switch which is there in the SAS panel. Okay. In the SAS panel, we have what is called as the gateways. Okay. We have what is called as the gateways. Now what we will do is we will study all these things in detail, like what are the key things each of these devices are going to do. We will study in the coming slides. Okay, similarly on the 33 kV side is the LV side. After stepping down, it is being stepped down in this example to a 33 kV. Okay. So when I talk about the complete automation architecture, we will have two. We will have SCADA server. In this SCADA server, we are going to see the status of our substation. Okay, and we have the gateways. Now these gateways are used to send the data to the control center. So all the information which are there in this relays, okay, are being collected within this gateway, and through this gateway we send the data, for example, to an SLDC, that is State Load Dispatch Center, or to a control center using different protocols. So we usually send the data using IEC 101 or IEC 104 protocols. So again, that data can be sent through different ways of communication. That means when we are sending a serial communication, we send the data using PLCC, that is Power Line Communication Carrier. Okay. If we are sending the data through, we can send the data through VSAT, or if they have laid a OPGW cables, the data will be sent on a network protocol like IEC 104. So the gateway in turn, what it does is it has got two activities. From the downstream, that is for all these panels which are there down, and this gateway, the gateway in turn collects all the data from all these relays and all the meters. So if you see below, all these are all the meters which are connected in a DC chain, and which in turn is connected to the gateway. Okay. So all the metering data, everything is finally collated within the gateway. So all the relay information, all the meter information, everything is there in my gateway, and upstream I am going to send this data to SLDC. Okay. And within the substation, in order to monitor the data, what we do is we have the software that is called as SCADA, where we are going to monitor the status of all my switchgear equipments and all the different protection status, metering values, everything will be done using the SCADA. This is just the overview. What we are going to do now is we are going to go in detail with each of these components so that we can completely understand how substation automation is carried out. The first main thing is, if you observe, for every bay we have got what is called as a bay control unit. For example, I have just stated as GF650. Similar to this, we have the BCUs from different companies like ABB, Siemens and all. They have their own bay control units. So, what is the objective of this bay control unit? Okay, so basically this bay control unit is used for controlling the switchgear. That means if I want to open my breakers or my isolators, all those things, I can do this control operation using the BCU. Okay, and for every bay we will be using one separate BCU. Okay. So whenever I want to do a control operation, I do this control operation using a bay control unit. This bay control unit, the control operation can be carried out using two things. One is using the BCU HMI. So this is called as the BCU HMI. Using the BCU HMI also I can do the control operation, or I can also do the control operation using the I control SCADA. Now, what is the reason that I require a BCU separately? Because when you see the technical specification of any substation automation, they would have told that you should not mix the production activity with the control operation. So we use BCU only for control operation. Okay. In some cases, but this is also a protection relay. It can also work as a overcurrent or fault relay plus do the control operation. But the specification says the control operation and protection operation should be separate. That is the reason we give protection relays as separate and bay control units as separate. See, the objective is at any point of time, even if the BCU is not working, it is fine. But the protection relay should always be working. That is the reason. Okay. And in addition to this, what we can do is we can also do all the logical configurations. Say for example, if I want to close the breaker, I need to see all the things within the substation are healthy. Only then I can close the breaker. Say for example, I have to check whether my breaker trip circuit supervision of my breaker, LVB is reset and isolators are closed. Like that I can create all these interlocks using the logic configuration within the BCU, which my colleague is going to show you how we can do logic configuration. Okay. So whenever the logic configuration is true, we create it as a virtual input. Okay. Only when if that virtual input is true, then only the control operation can be carried out. So what I do is, if I try to close my breaker using the SCADA, when the operator does it, what it does is it will check all the interlocks are satisfied. Only if all the interlocks are satisfied, only then the control operation will be done. Okay. The main thing is all these BCUs communicates on IEC 61850 protocol. What is IEC 61850 protocol? It's a protocol which has been standardized for substation automation across the world. In India, whenever we do any substation automation, we always give IEC 61850 release. And what are the advantages of 61850 release? I will take it in the coming slides. So basically, the advantage is that it can support multi-vendor, and there is no. The thing is, it is there is a standard set of objects and classes which has been defined, using which every operator has to be compliant with that. Only then it can communicate. So next thing is, now all these things we saw that these Ethernet switches, whatever, all these relays are finally going to be connected using an Ethernet switch. So again, when we talk about networks, so we will be having these Ethernet switches. There are different redundancy types also. Like we have got what is called as RSTP. RSTP is Rapid Scanning Tree Protocol. Okay, we have got what is called as PRP. Those are all called as network redundancy protocols. When you observe the previous slide, I forgot to tell one thing. The thing is, the redundancy is applied when I do automation. When I do automation, you can see the screens. So there are two SCADA servers, SCADA server 1 and SCADA server 2. Okay, that means even when one is down, the other will be automatically working. Okay. Similarly, when I talk about the gateways also, you have gateway 1 and gateway 2, because the data has to be sent continuously to the SLDC. So even when one gateway is down, automatically the other gateway which is there in standby mode becomes active. Okay. So here whatever we are seeing here in this screen, this is a typical SCADA screen which we have developed for the customer, where actually what it indicates is the red color indicates that it is not communicating. Okay, whereas the green color indicates that it is communicating. Okay, this is just a screenshot. Okay, and in addition to that, you can also see what is the current server. That means whether a standby server is there or the active server is there, even that status can be seen in SCADA.
If the main server or the gateway is not working, it will give a notification.
Yeah, it will give a notification. It will automatically detect. It will automatically detect and it will automatically do a switch over. So standby becomes active. Then what I can do is, once I have rectified the gateway or let it be my SCADA server, what I can do is I can do a manual switchover. Make again the primary as the main server and the standby will continue to be manual. Okay. So one is the Ethernet switch. The next component comes our gateway. So the main objective of the gateway, as I told earlier, it is going to collect the data from downstream devices. On the upstream, it is going to send the data to the control center using IEC 101 or 104 protocol. Our gateway supports up to 8 control centers. That means the data from my gateway can be sent to the 8 masters. Okay. Now, for example, in Karnataka, where we are doing for KPTCL, we are sending the data to 4 masters. Okay. So they have a SLDC center at Anandrav Circle. They also have at Nelmangala, and they have one more at Rajasnagara. We are sending the data to all those places. Okay. And all this data, whatever they are receiving, is going to be stored in their SCADA servers. So when I talk about Ethernet switches, they are used at the bay level and at the station level. Now, if you see every control panel, again it depends upon the specification or the requirement of that particular substation we are doing. Actually, all this automation architecture depends on the utility to which you are doing. Every state follows a different standards. Okay, some people what they do is for every 3 panels you give one switch. That means panels means control and relay panels. Okay, every 3 panels you give switch. For some states they tell every panel should have a single switch. Okay, so all these things are connected in a ring network, and finally in this SAS panel we will have 2 Ethernet switches. Okay, and just show you. If you have any doubts or anything, please stop me at any point of time. I can. So if you see here, there is a Ethernet switch for every panel here, and all these things are connected in a ring network, and there are 2 Ethernet switches which are there at the SAS panel. Okay, this Ethernet switch, this is what we referred as a ring net. So when I talk about different protocols, see the product, the gateway, it supports multiple protocols. That means if you see here as a master, that means from the downstream devices, I can read the data in IEC 101, I can read the data in IEC 102, 103, 104, okay, and it also supports, I can read the data in IEC 61850. IEC 61850 is a suite of protocols where it supports both MMS and GOOS, okay, and in addition to that, it supports DNP3. Okay, DNP3 is a protocol which is basically being used in US and Canada. They use DNP3, whereas in India we use IEC 61850 protocol. And we use DLMS. Now DLMS has become a de facto standard for communicating data. Earlier we used to read the data in Modbus. Now the data is being read using DLMS. See, advantage with DLMS is they have specified standards like 61850 where irrespective of the meter manufacturer, I can read the data with specific addresses. That means it is standardized. Okay. So, and in addition to that, there are protection relays. One is we saw that we read the data from the bay control unit, and then we also read the data from the protection units. Okay, this protection relays, again here there are different types of relay. It can be a distance protection relay, or it can be if it is a transformer panel, it will be a differential relay. Okay, and if in addition to that we have to read the data from an RTCC panel. Okay, wherein I want to see the tap position, winding oil temperature, all these things, that also we can read from a transformer relay. And one more major component is called as the GPS. Okay, so when I give a SAS panel, this typical SAS panel will contain Ethernet switches, will contain the gateways, and for something what we do is we also fit in our SCADA screens or the SAS systems into the SAS automation panel itself. Now here what happens is GPS is used for time synchronization for all the relays. So basically when we are doing some time synchronization, we are using an SMTP protocol for communicating the data, synchronizing the time with all the relays. Now I will tell you what is the difference between, now I told substation automation using a bay control unit. So the new substations, whatever they propose, say for example in Karnataka, up to 132 kV voltage level, that is up to 132 kV voltage level, they use the remote terminal units. Above 132 kV and above, that is 220 kV, 400 kV and all, they use a BCU type of an architecture. So what is the difference between RTU and a BCU? See here what we do is the RTU basically what it does is it is similar to your BCU, but it does not have an HMI. Okay. Now what we prefer doing it is, say for example, there are legacy substations. There are old substations. For the new substations, they always give a specification till they require a bay control unit, that is with HMI, where they can control the operation through a bay control unit. We can also do it using an RTU. Okay, you can use it doing an RTU. See, the RTU is nothing but this one. So that is the BCU, whereas this is the RTU. Okay, again there are different types like digital inputs and digital outputs. Okay, this is an RTU. Why I require an RTU? Say for example, I have an old substation where I don't have any communicable relays. So I don't know the status of my breaker, all those things, or maybe say I want to know the status of my master trip relay, or I want to know the status of my trip circuit supervision relay. So what I do is, in that cases, in the legacy substations, we provide them with this RTU panel. Okay, and in each of these control and relay panels, we give what is called as a contact multiplier. Using the contact multipliers, whatever status which is there, they would have given it to their annunciator. Okay, where there is no SAS there will be annunciator there. To the annunciator, they would have given the breaker status, switchgear status, master trip relay status, all those things they would have given to the annunciator. Okay, and this status, what I will do is I will put it to my contact multipliers, and that I bring that wiring connection to my RTU panel, and then that data I will send the data to using my gateway. That is how what I do is I convert my legacy substations into substation automation activity. Okay,
He said it's only a PLC unit. What are the controls inside?
no, see, it is same as a SAS panel. What we do is we instead of what we are doing is we are giving a set of RTUs. Now here in this, for example, all these are RTUs. Within the RTU panel, I have given these RTUs. Okay, so all these things was what we used to do is every panel we are going to put this BCU. Instead of putting BCU in every panel, because if there are already control and relay panels existing, I cannot insert a BCU into that because I have to make a cutout, then I have to fit in this relay. It will be very difficult for me. Okay, and I need a Ethernet switch, all those things. Now to avoid all these things, what I do is I give one RTU panel. Okay, and then whatever wiring, existing wiring is there through contact multipliers from the control and relay panel, I get it to my RTU panel, and within the RTU panel, I connect it to this contacts. Okay, now using this contacts, what I do is I connect this to SCADA, and this can communicate the data to the SCADA. Now in SCADA, I can read the status and I can show it. So that is how we are giving solutions to the legacy substations where there is no numerical relays for communication. Okay. Am I clear why we use RTUs? Okay.
So it means it takes the data from the panel and will display
Correct,
the
correct.
scan.
Basically, it is going to take the status of that breaker status, all those things. You have your NONC contacts in your breaker, which would have been brought to the panel. From the panel, I am going to take it and give it to this. And this I am going to show it in an SLD, wherein it helps me to identify what is the status of my breaker, what is the status of my insulator, all those things it will be, I am doing it.
So this will not do any control action.
Control also action can also be there. For that we have digital outputs. I have digital outputs also. You have analog inputs for reading the analog values. You have digital inputs for identifying the status, and you have the DO operations can also be done. Okay.
It's like a completely PLC unit inside.
Yes. So that is why what they do is I again come back to what we have done in Karnataka. So we have been approved both. So we call this as an RTU panel, and the other one we call it as a SAS panel. What is the difference between a SAS panel and an RTU panel? The SAS panel will have a BCU, whereas an RTU panel will have my RTU units. Okay. So here, if you observe each of this, it's a combination. It depends. For example, in Madhya Pradesh and Karnataka, they don't use a SAS panel. They use a RTU panel. Okay. Only difference is I am using an RTU instead of a BCU for control operation. Okay. Now, if you observe the architecture here, we have a 132 kV feeder. 132 kV feeder has got a distance protection relay, and 132 kV transformer has got a differential protection relay. Okay, and we have 132 kV bus coupler, which is again a distance protection relay. All these relays are, if you observe, it has been connected to an Ethernet switch because it communicates on IEC 61850. And every feeder or every panel have got a multifunction meter which have been daisy chained, and which again is being converted to a, and these meters are communicating data on Modbus TCP/IP. Okay, which in turn is connected to a Modbus TCP/IP converter and again connected to the switch. Okay, from the switch we have connected to a SCADA PC, wherein I am going to get the status of all these equipments within my SCADA. Okay, in addition to that, if you observe the gateway, and all the data from the Ethernet switch comes to the gateway, and using the gateway I send the data to the control center. Okay, now the advantage is from the control center I can also do the remote operation. If I have to do the remote operation, then I need to make my SCADA in my into remote mode. Okay, I can change it to the remote mode, or I can make it to local. If I turn it to local, then the control operation can be carried out only through the from the substation, not remote. So this is just a other example what we have given. We have this is the main RTU, and there are other sub RTUs which are there. It again, it's just an example, like we can connect to multiple RTUs, and which in turn is connected to the main RTU. You have another RTU which is connected to the protection relays, meters and other IEDs, and then you can see the data in local SCADA, and my gateway has got the capability to send the data in IC 101, 104, DNP3 or Modbus. Okay. It is similar to what we are doing. There are multiple RTUs. Okay, I'll just brief you out now. In the utility like Karnataka, they have standardized the RTU panels should be like this, irrespective of the substations. Say for example, in Karnataka, what we do is we give a RTU panel which has got 144 DIs, 144 DIs, 80 DOs, that is they require 80 digital outputs and 24 analog inputs. Okay, based on that, what we do is we select the different modules of our RTU products and we configure our RTU panel. So we as this RTU, we call it as an IRTUE because it is nothing but an extension unit. So we use IRTUEs for the operation of the breakers. Okay, for operation of breakers, and it is also used for, as I told you, for the reading the status of the feeder panel. Say if I want to get the status of my breaker, my SF6 gas, that is of my breakers, the gas low alarm, Marshall trip relay status, and if it is a transformer panel, I will get buckle strip, oil temperature tip, winding trip. All these things are connected to the digital inputs of my RTU. Okay, in addition to that, I want to see the status of my battery. Okay, and you have transducers there which is going to give me the data in analog inputs. Give me the data which will be connected to my analog inputs. So it is just different configurations what we have. So this is one of the units what we are having. Okay, here this has got 24 DI and 8 DOs. This is called as a digital inputs, and this is called, there will be two cards. This is called as a card and this is called as a B card. The A card has got 24 digital inputs and this has got 8 DOs. You can select different combinations. So in a technical specification, they would have written how many DIs they require for the substation. So as per that, I select the combination and I prepare the drawing and I submit it to the utility for approval. Okay. Now here in this case, so what I wanted to tell you is we have different modules. So we have D1 module. What is D1 means? It is digital input 1, digital input card, another digital input card. So every card has got 24 DIs. That means it will have 48 digital inputs. Okay. And similarly, we have R1 card. That is each card has got 8 relay outputs. Totally 16 relay outputs is there. Okay. Similarly, we have analog inputs. So using different combinations, I can design my RTU panel. Okay. Again, this is just an example of our product. The similar requirement will be there, similar thing will be there in, say, if I buy a ABB RTU, I will select the modules as per my requirements. Okay, and this is about digital inputs. So again, these digital inputs can become high or low. So if it depends upon my rated input voltage. If I can give 24 volt DC or 48 volt DC or 125 volt DC or 220 volt DC. The DC can be of any levels. So how will my DA become high? DA can become high when the voltage is greater than 85%. Then only my DA contact becomes high. You are able to follow, right? Yes. Okay. So similarly, when I want to read my analog input values, I can read from 4 to 20 milliamps. Okay. So I have relay outputs also, and each of these they have a maximum rating. If it's a 220 volt AC, it has got 8 amps as the maximum rating. That is nothing but my contacts. Okay, how much cable, how much of current they can handle. Okay, if it is 30 to 20 volt, this one, then it is 0.12 amps. So what we do is we have HDR relays. Okay. So that which is able to handle the heavy current, so that my contact is not burnt. Okay. Next is, see, the thing is all this extension unit is what we were talking about. For example, when we are doing I want a 144 digital inputs mix, I have to get a collection of this type of boxes. So how I am going to connect it? Each of these boxes are going to be connected in a DC chain. Okay, they communicate on RS422 and they communicate on Modbus, or it can also be communicated on BUS. BUS is a protocol which is used at the peer-to-peer level in 61850 protocols. So this is how the thing is, when I am connecting many devices in a DC chain, each of these devices need to be identified with an ID. For example, if I connect the meters in a serial, this one, each of this meter will have a meter ID, just like how my system has got a IP address. Similarly, I have meter IDs for each of these things, which uniquely identifies from where the request is coming, so that the response can also go appropriately. Similarly, for my extension units, we have what is called as a dip switch. Okay, so using that dip switch, I can set the ID of my extension unit. Okay, and each from a single port of my main RTU, I can connect up to 15 devices. Okay. Now this architecture, what I am showing you, it is called as ADLS. ADLS means automatic data logging system. Okay. What is meant by automatic? See, some states, what they do is they don't do control operation. They want only logging. Now in that case, for example, if it is some states like Chhattisgarh and all, they don't want to use, they are not using any control operation at the substation level. They want it at manual only. Okay. For them, what we do is we provide what is called as data logging system. The architecture is same. We read all the data, everything, we show the data on SCADA, but we don't do the control operation. Okay. So whenever I want to configure this device, okay, whenever we want to configure these devices, we have a configuration tool. Okay, it is called as iconf, which my colleague is going to show you how we can configure those devices. So we have this gateway, we have our iControl SCADA. So we have a lot of devices which are there in the substation. Now I need to configure my gateway to read the data from all these relays, all these meters. So I use this iConf configuration tool to add all these devices to my hardware, that is to my gateway, so that I apply the configuration, then my gateway starts communicating. Okay, for that we use this iConf tool. Okay. Similarly, you have iControl SCADA. Okay, iControl SCADA is again the name of our SCADA, which we use for our building up of our SLD and show the online status within the substation. Okay, so let it be any manufacturer or any relay. We have seen it supports all the protocols. Okay, it supports all the protocols. Like we have seen that it supports DNP3, IEC 61850, Modbus RTO, Modbus TCP. So all this data which we communicate, the data can be shown within this SCADA.
What is the different color line color indication?
I'll see, it is called as line coloring, whether the bay is charged or not charged. Okay, I can define those colors. Okay, we'll show you with the live this one with this SCADA, where see if the breaker is red means it is closed, if it is green means it is open. Like that you have different standards what we follow. Okay, which will indicate the status of the substation. Similarly, we will show whatever is the current, voltage, frequency, everything we will show in SCADA. Okay, and if it is not, if the device is not communicating, it will indicate it as red color. Okay, if it is communicating, it will indicate it as green color. So there are different standards which we follow. So there are, when we talk about SCADA, okay, each of these companies have their own SCADA. For example, if I talk about ABB, their SCADA is called as micro SCADA. If I talk about GE, it is called as their SCADA is called as Simplicity. Okay. Similarly, you have Alstom, they call it as their Agile software. Similarly, our software is called as an iControl SCADA software. The advantage of this SCADA software is, see, usually what happens is whenever we do the automation software and we install it in SCADA, all those things, these servers are always prone to virus. Okay, because they start installing many software, it crashes, all those things. But what happens is, if we install our SCADA, you don't need to do any installation. That means you just need to copy the folder. Whereas if you do other SCADAs like Simplicity and all, if I have to do the installation, it's a very big process. I have to do the installation of my database. I have to see that the appropriate DLLs are there, all those things. Whereas in iControl, you just need to copy the folder and automatically my software starts installing, starts working. Say I want to install in this laptop, for example, I just need to copy 2 folders, and then if I start my application, it starts working. But only thing what I have to do is I need to have my dongle. If I have the dongle, it will check the license and it starts working. So why I am telling you this is, the objective is tomorrow if I want to, for some reason the system has crashed. So I always have a backup. What I can do is I can tell the person who is there at the substation, okay, just to copy the folder back and the application starts working. So the maintenance is easy. Okay, I don't need to send an IT guy there who goes there, removes all the uninstalls it. Sometimes uninstall is not successful, then I need to delete it. Sometimes it may go to a level where I need to reinstall the OS also. So all these things are avoided. Okay. And it is easy to back up and maintain comprehensive HMI development tool for supervision and control capability, and we can monitor all the alarms, and it supports multiple protocols. So here, as I told earlier, we have two SCADA servers for redundancy, one runtime system, and line coloring of base. That means you can identify which bay is charged, which bay is not charged. All these are the features of our SCADA software. And then, say for example, any faults occurs in my village, automatically it downloads those DR files from those relays into my SCADA, so that the MRT team, that is the relay and protection team, they can analyze like what was the fault, all those things. So these DR files will be automatically downloaded from the relay to the SCADA servers, so that they can do for further analysis. And it also reads not only reads the data from my SYS1850 relays, but also reads from my RTU units, where I can read the analog input values, digital input values, and I can carry out the control operation of my breakers. And the other things, these are nothing but the features of the software. That is, you have a password protection, and you can display the alarms, events, trends. And we can switch between local and remote operation. And data, whatever data which we are receiving in our SCADA, that can be stored in a database, like MySQL database. We can store the data. In addition to that, you have the reportings, which is as per the substation requirement. The reports can be downloaded. These reports can be in PDF, XLS, HTML. In different formats, the output of the reports can be generated. In addition to that, what are the other components which we saw? You have the printers, you have the communication cables, and you have the industrial grade servers for SCADA redundancy, and you have what is called as an engineering workstation. The engineering workstation is used because I need to do the configuration of my protection relays. Say for example, I have this GF650 relay or an Armstrong relay, then you have a relay configuration software. All these things will be loaded in the engineering workstation, through which if they want to do any further modifications or further change in configuration, that software will be installed in the engineering workstation. We don't install it in our SCADA PCs. And you also have an auxiliary BCU. This is for the auxiliary equipment within the substation. I want to know the status of my batteries and fire extinguisher units, all those things. That status is maintained using that. And you have also called the LIUs. If you are connected in an optical fiber units, so whenever I have armored depot, we connect it to LIUs. From the LIUs, that is light interface units. From there, you connect it to the switch. And then you have power line communication modems. So these are all together forms the status of the altogether forms the total requirement for your automation. Any questions you have or anything? Because the thing is, we do the projects day in and day out, and I just kept on telling about all these components, because for you, if you have anything or anything which you want to ask me about, any clarification, you can ask me.
Since we have that minimum knowledge with respect to PLC, somehow we could be able to manage PLC, because it's more or less it's like PLC, what is the motor, sortie or VC, whatever we have. So it takes the input, it gives the output, so it's completely like PLC operation. Only thing is, this communication protocols we are not aware of.
So for that
Mostly
reason,
what we do for PLC, the campus communication tools, it's all completely different.
the main thing is when I talk about substation automation, main thing is about the protocols. Ultimately, if I have to read the data in SCADA, I need to know about the protocols. Okay. If I talk about meters, meters communicates on different protocols. If I talk about a relay or a BCU or a bay control unit, it gives me data in IEC 61850. So if I have to do substation automation, one thing is I need to know how to develop my application on SCADA. That means how to build a SLD, all those things. The main important part is how is the data getting communicated to my software. That is, it depends on the type of the protocol through which it is going to send the data. So for that reason, we wanted to make this not too technical, this one. That is why we have brought the devices so that we can show you how you can read the data from the meter and how you can see it in SCADA. Okay. Similarly, I will show you a bay control unit also, using which what I will do is I will read the status of my digital inputs and we will simulate that and we will show you. So practically we want to show you how we typically work in a substation so that you can just understand, because I have been too technical in doing things, I understand that. Okay. So what I wanted to do is I wanted to make it more simple in such a way that you are able to understand like how it actually works within a substation, at least get an overview of it. That is the objective.
So you will have your own IEDs?
Huh?
Your own IEDs?
Yeah, we have our own RTUs. We have our own RTUs. We have our own I control SCADA. Now all these things I cannot use it directly in any utility. It requires a certification. Okay, so ours is certified by KEMA. Okay, it should be KEMA certified, or you can also, that is an international organization. So when I talk about the other big companies like GE or ABB or Siemens, they also are KEMA certified. So if I have to work in any of these utilities, for example, let us say KPTCL, first thing what I have to do is I have to go there, show it to them, and they will check everything. After that, I have to go to their SCADA team, which they will test it for 6 months or 7 months. Once they feel it satisfactory, then they are going to give us an approval. Only if you have an approval, then the EPCs will place an order on me. Okay, that happens in every utility. Okay, so we have been approved in most of the utilities across India. Okay, so in Karnataka itself, we are now commissioned around, we have around 70 RTU panels have been deployed across Karnataka. Okay, similarly, we have done this, that is about the RTU. When I talk about automation, we have done in different states, like we have done in Haryana, we have done in Pitkul, that is Uttarakhand, we have done in Assam. Okay, and again I was talking about this Madhya Pradesh. We have done in Madhya Pradesh. They use RTU panel. Different utilities follow different standards for different voltage levels. Okay, when I talk about Madhya Pradesh, they have RTU panels up to 220 kV. They use RTU panels. 220 kV and above they use SAS. Similar is Karnataka. Whereas in Assam and all, they use SAS panels for right from 33 kV to 220 kV. They use SAS.
Sir, in Karnataka, how many substations are automated in percentage?
Almost all the substations are automated. There are more than around 2,500 substations.
So, in Karnataka, almost all are automated.
All are automated. And most importantly, all these substations have been connected on the VSAT network. Okay. So when you talk about the technology wise, all those things, and that VSAT was implemented long back, 10-15 years back itself. So all this data from all these 2,500 substations comes to the load dispatch center at Anandrao Center. So when I do a substation automation, say for example I am talking about the 70 substations. So when I commission my RTU panel, first thing is they are going to come to my factory for inspection. Okay, there I have to do a complete run of my panel. That means I have to do like how we do the setup here. We have to simulate all these values, connect the meters, everything, show it to them so that when the panel goes there, it should work 100%. So they do the factory acceptance test. After the factory acceptance test, the panel is dispatched to the site. Then we have what is called as site acceptance. So my SCADA team, my team goes there. Okay, we stay there in the substation for week to 15 days. We see that we come. I showed you the architecture diagram. We connect all those meters, everything, and we see that all the data is coming to my gateway. Then what we do is we talk to the KPT cell team, which is there in the head office, whether they are receiving the data. Once they receive the data and they have tested everything, then they are going to give me the sign off of the project. Okay. Before that, they tell me for manufacturing, I have to submit the drawing, tell them about, explain about all the things, what they require to their SCADA team, like how we are going to achieve it. They go through it, they will tell some more questions, all those things. We modify the drawings, then they put a seal and give that drawing is approved. After the drawing is approved, then what we do is we release it for manufacturing. Once the manufacturing is complete, we inform KPTCL that it is ready for inspection. Their team comes there and they spend a day or two in our factory. They thoroughly test it and they put a seal that this RTO panel has been tested. That is how is the process. Similarly, when I complete everything, I also take a sign off from them telling that the RTO panel has been successfully commissioned. This is the process.
That gateway control what you have shown,
Yeah.
is it a standard one from your point of view?
Yeah, it is a
Or
standard. No, it's a standard one. See, the thing is, when I take the approval, what they do is they take all the test certificates, everything from there, and I have to specify the models also. Okay, only those models has to be used in the project. I cannot change the models also. Okay. Similarly, if we are doing a control and relay panel drawing also, they will check what production relays I am using. Okay, what models they are using, how much digital inputs they are having, how much analog inputs they are having. Okay, all that thing will be approved by the relay team and the SCADA team. They verify it, they check it, then only we place the orders to the vendors to procure it. Here in this case, this is our product. Then only we procure these items and we do it.
So the same software, sir, in Metro, BioNanda, they are using like
Similar to that, it is same, it is all same.
same.
Same, it is all same.
There is no limitation in the software with number of nodes because every substation will vary, right?
Right.
So how will you this programmable this or customized software?
No, it is not like that. See, whenever I procure this SCADA software, okay, it depends upon the number of tags. We call it as tags. Number of tags which are communicated. Okay, so we have a different price tag for different things. Say up to 2,000, we have got a different price tag. More than 10, 15,000 on the price tag. And there are some things like if I have to put this software at a control center level, where I have got thousands of substations from where I will get the data, then for that costing is different. Okay, so based on the requirement, we are going to do it. Now, if you see, as I rightly said, if you see a metro, in the metro below, when the train comes, you can see an RTO there.
Yes.
Okay, RTO, it is nothing but the status, it is being transmitted online to the control centers, where they are, which is there in Bayapnalli, all those places, where they monitor the movement of all these vehicles, including the status of certain parts which is there in the train. So all this is connected using the RTO. So ultimately, when I talk about all these things, it finally comes down to digital inputs, digital outputs, and analog inputs, and combining all these things to create what is called as an interlock. And if the condition is true, based on that, we do some preventive or control operation.
Once you complete your process in any substation if you make, Afterwards, what will be your role there?
Now the thing is all these devices, whatever we provide, it has got 10 in 5 years validity. Now we have implemented it right from 2014 till now it is working. These are all devices. See why this is a gateway. When I talk about a gateway, it is again a software, okay, which is being loaded into this and it is running. Why we are giving it as a separate device is it allows me that if I put it in my SCADA server or in my PC or in my laptop and the same software, the chances of that getting corrupted is because I daily use it and I may install other softwares. But the data is very important and very critical for me to send that information to the control center. So how do I keep it, always make it working? I just dedicate a device for this so that no other software is installed. That is why we give a separate hardware device. It is nothing but a software.
The same protocols and Modbus protocols.
Yeah, same protocols. See, the thing is, when I talk about this, our product, it supports many protocols. Okay, see, here you see that these are all the protocols which it is supporting. So IEC 101, okay, you are talking about Modbus RTO, Modbus TCP, DNP3, 61850. All these things is from the downstream. That means from there I am reading the data to this. Now from my gateway, I want to send it to the masters. Then again we can send the data in 101, 104, and even my gateway can send the data even in 61850. That is upstream. So downstream devices I can read it all these protocols. Similarly upstream also I can send it in whichever protocol I want. Say for example like what I am showing here, I can send it in 101, 104, DNP and Modbus RTU, Modbus TCP and even 61850. If I communicate on 61850, we have got what is called as an ICD file. I need to give an ICD file so that that data can be read by the person who is reading from my gateway. So I create an ICD file and give it to the customer, and customer will read it in this SCADA. So to that level it supports all the protocols. So it can be based on the customer requirement, we take the licenses of different protocols. Any other questions you have?
Sir, can we take a quick break for a short while and we'll some
Yeah.
within after 10 minutes?
Okay, no problem. I just have one or two topics to show.
Yeah.
After that, it will be practical discussion. Okay? Thank you. You can do that. See what happens. We have what as a DR files. We have got the DR files. Okay, those DR files, using those DR files, I can identify. Not to that level. Focus to your
Profile is completely uneasy. It's not authentic. Which has changed that. Begin with it, and then time yeah, that happens. Then after that, we go to the flow. See you. Now, and program outcomes also. Second, data analysis, reservations, reservation part will come also analysis. This level. So, the is applying. From four of the by analysis. And
A demo about the application, what he has developed.
They'll come, we'll be here. Let's wait for 2 minutes. Yeah. Because somebody is trying to order music, they cannot understand. In few more minutes, come to this. Yeah, 2 minutes. Just post the section. This is some other plants dashboards.
Yeah, it's a plant study. This is a solar plant. I told you the VET.
Yeah, right.
VET solar plant. That solar plant we have commissioned. Okay, it is live. So we will just explain about the solar plant. How we have used SCADA to get that this one. Okay, so he has commissioned it. Okay. So he is going to explain. Okay, all those things.
Yeah, I can start.
First of all, good afternoon.
Now currently I am going to explain. I am taking two SCADA recently commissioned substation only. One is VT solar park, another one is Bangalore substation that is located in Rajasthan. Why I am choosing that two substation? Then I will tell you clearly. Mainly I choose the VT solar park, means that is one generation substation. How power is producing, everything I will go into the detail. If you have any further developments, you can ask anytime also the issue. How we are giving our solution in this project, that also at the same time I will explain also. Then another one project is called the substation project, that is only full substation based project only. That how it's work, everything will go into detail step by step. First we are entering to solar power plant. Before we are starting this one, everybody should go for imagination mode, means this will be look very nice and more interactive also. Let everybody assume one big solar power plant is like that. Everybody will assume. First we will start. First, if you come into solar power plant, first thing is solar string. First we should know what is solar string. Solar string means combination of solar power plant, solar panels are there. Nearly one string they will connect up to 20 to 25 like that, based upon their requirement, based upon their architecture it will come. Okay, if you are coming in one string already we told 20 panels are there. They are connected in serial only. Here I mentioned that solar string current, how we are getting the current, strings current, everything we are showing here only. Next we are going to next one is SMB. SMB means they are called as string monitoring box. That is combination of solar strings. If you come into one SMB means almost 24 solar strings will be there. Already I told solar string means combination of all solar panels. That all string they make it together, they will connect into SMB. SMB means string monitoring box.
Just to add what Ajit is telling. So usually what happens is it depends upon how much area we have got for the solar plant. Based on that area, what will we have the solar consultants. And it is our budget. It is also very important. How much of power can be generated and how much of area we are having. Based on that, the solar consultants are going to give you a design about how my plant will be and how many strings. He is calling about strings. A string is nothing but a collection of panels. So how many panels has to be there in one string and how many such strings can be connected and how many inverter rooms I require, how I can distribute it across different inverters.
DTR.
Say for example,
DTR.
Correct.
Detailed project.
Correct. So the thing is, what we have to do is, say for example, I have an area where I have to generate 10 megawatt. Then what I will do is, I will, for example, I am talking about this Velamur plant. 10 megawatt means what they have decided is, they will have 2 inverter control rooms. Okay, each one of 2 megawatts, which they are generating through that inverter. That inverter, where will it get that power? It will be getting that power from the panels. These panels are again distributed as string monitor boxes. A single string monitor box, for which Ajit has already shown, it has got 24 strings. So what is one string? One string is collection of how many panels is it?
20 to 24.
Okay, 20 to 24 panels will be connected as one string. Okay, that strings will be finally connected. Now if you come closer here, now one inverter will have so many string mounted boxes. You can explain.
If you come to inverter means collection of all SME,
All string
monitoring box. That all string monitoring box they are connected into the parallel only. Because they need to maintain the same voltage. That's why they are maintaining parallel connection. If you come here we can get to know all the inverter data. I mean here today generation,
I mean, how much generation today they are generated from morning 7 o'clock till now. Then if you are coming to active power means current generation of the inverter. I mean, how much power current is generating that it is showing. If you
All this data, whatever, I will just keep on adding wherever Ajit is doing. So how is this data coming to my SCADA? The inverter has got it gives me the data in a particular protocol. For example, here this is a inverter of, for example, let us say ABB inverter. This inverter gives me the data in Modbus TCP. So what we would have done, we would have connected this inverter's Modbus TCP IP port, that is my RJ45 port. I would have connected it to my switch, and that switch would be connected to my gateway. So my gateway is having all this data. From that gateway, I am going to read that data. You can show the architecture diagram.
It's a just coming this one. Here next we are coming. UV means that RY model. UV means that is American standard something like
Line voltages.
line model. Here next frequency, then power factor, and bus voltage. How much bus voltage coming from the SMD, and next DC current. How much current coming from the SMD. That also we are showing in the imaging of the. Next, if you are going, how much current is going to ground also, that also matters. Next, there is ambient temperature. If you are coming, if you are, have any device means we should maintain great ambient temperature. I mean, their device already they are specified 30 to 40 degrees Celsius, something like that degree we should maintain. That's why that parameter also plays a main role. Next, IGBT. IGBT means we already know IGBT means is converting DC to AC voltage. That device temperature also very mandatory, because otherwise if IGBT is going to malfunction means the entire inverter gets corruption. That's why we need to know, these are very mandatory things. That's we are showing here. I think now you are understanding what is SMB, what is storage field, what is a inverter. Now next we will go to next, if you go to any renewable, if a solar power means it's full and full depend upon the weather only. We need to know how much radiation is there, how much average radiation, how much is humidity, and ambient temperature. All the things we are showing there. Okay, I got all the parameters what we are showing in SCADA. Next I am going to how we are communicating to this data to the SCADA.
Before Ajit goes to next one, now why is this weather monitoring system required? See, the thing is, all this data, whatever Ajit has only configured, we are sending the data to SLDC Madurai. Okay, but how much of power is getting generated? Now, usually what happens is, they would have promised, for example, let us say in this case it is TNB, that is Tamil Nadu Electricity Board. They would have promised that they will give. If generation is 10 megawatts, they would have promised at least 8 megawatts they are going to give. Now, for some reasons, there might be a reason where it may be a rainy day or it may be a cloudy day, I am not able to generate it. Okay. But the thing is, sometimes what happens is, because of poor maintenance, the transformer is not working or anything like that, they may not be able to supply the power. Then it may attract penalty. To avoid that, what they do is, they take this weather monitoring data also needs to be sent to the SLDC. So they cross check. If you are not able to generate the power, is it truly because of the weather? You understand? No? To that level, the utilities are now improving. So if I am using a wind turbine, we call it as a WTG, wind turbine generator. So wind turbine generator data also has to be sent to SLDC. I cannot simply tell the fan is not working. That should be proved with data. Okay. So this weather monitoring system is being, we have to install a weather monitoring system whenever we have a solar plant. So that whenever the generation what is happening should be in compliant with whatever statistics which your weather monitoring system is showing. Okay. Say in case it is because of the poor maintenance of the plant or anything like that, then it attracts a penalty. You have promised it and you are not delivering it.
Next we will go to dashboard. Here what we are showing means just we are showing inverter wise how much voltage is going, how much current is going, how much active power is going, everything we are showing. Here we are showing daily generation. I mean, they are already told, I mean, one inverter per day it will generate 1.2 megawatt. Means I am mentioning here kilowatt only. If morning 6 o'clock means it will generate 1 megawatt. Step by step it will increase.
So it will be gradual increase.
Gradually increase. Next, we'll go for, I mean, how we are getting this data into the SCADA schema. Just we'll go to communication speed. Okay. First we come to the inverter. That inverters are already told that inverter already have that Modbus TCP port. That protocol only we are connected to. Here one switch is there. That switch we are there directly connected. Next, if you are coming to SMB means we are using serial communication. I mean, how we are making this communication means here SMB1 is there. SMB1 to SMB2 we are making serial communication. I mean, serial communication in the sense that is RS485 cable only. From SMB1 to SMB2, SMB2 to SMB3, SMB4 to SMB5. Everything we are doing, finally it will come into the here on advanced gateway itself. I mean, data means this gateway functionality is very easy only. It means it will convert Modbus RTU to TCP/IP. RTU is RS485 communication. If you are coming to more data means it will connect serial communication to making parallel communication. Like that we are making all SMS one by one. Here we have two ICR rooms. I mean, they have two control inverter rooms. One is ICR1 and ICR2. ICR1 have three inverters, like 1, 2, 3, 3 inverters are there. Then here, if you are coming here, same 3 inverters are there. Here, if you are notice here, wherever the blue line is coming, we are using LAN cable. I mean, gas 6 cable we are using. Wherever we have mentioned, this one is yellow color means we are using serial communication. Means for it. Actually, if you visit any solar plant, means that IC room little stay away from the master control room. From ICR1 to MCR more than I think around 1.5 kilometers. From ICR2 to ICR MCR around again 1 kilometer. We already know about that. If you are using here LAN cable means it will not communicate, it will not transfer the data. Because if you go for LAN cable, it will only support 100 meters away. Here distance is very more. I mean more. I told already around 1.5 kilometers. That's why we are using FO cable. Means that is fiber optic cable. It will support 2 kilometers up to 2 kilometers. Here around approximately 1.5 kilometers only. We will go with FO cable. We will start with the communication. Then if you are coming to here hybrid gateway will be there. Means gateway means it will support all the protocol. I mean this innovator coming from Modbus TCP/IP. Modbus TCP/IP. Here also we are already converted. Means Modbus RT to TCP/IP already we are converted. Same. That's why this also coming same Modbus TCP/IP. So here almost all data coming in Modbus TCP/IP. If you are coming here, one MOFM is there. That MOFM we are connected directly to our gateway also. Means there we are making RTU. I mean RT communication. In our gateway it will support both serial and TCP. Both it will support only. That's why we are connecting the MOFM directly to this our gateway. Finally, we are getting all the data using our gateway only. Then we are sending data to our SCADA also. I mean, SCADA means it will refer to all data. This SCADA only. Then there we are placing on a reset modem. That reset modem it is using to establish the communication between SLDC to that substation. From here to here wireless communication only. From our gateway we will send the data through this modem. Then finally the SLDC people get the data also. This is how we are execute this project. In this way, anybody have any doubt, please ask it.
Able to follow.
Okay, sir. Next, then this is one generation substation. I think hope everybody understands clearly.
So that ICR1 and ICR2,
Yes.
the distance is limited with that MCR, no?
Yes.
Restricted limit. Okay, suppose we go beyond that 2 kilometers. You told below 2 kilometers using that
Day4 cable.
Yes.
Go for more than that. What is the type of communication?
There we are using this, already we have the reset model to same.
Here in the
No, SCR to MCR.
SCR to MCR.
Ah,
So distance should be more than that.
Then we go for same SLDC, whatever we are.
Wireless communication.
Yeah, wireless communication, what we can do is there are different types of communication options we have. Okay, we can set up our Wi-Fi router type of
Router.
I can set up a Wi-Fi setup also, and through Wi-Fi also I can communicate. Okay, nowadays the thing is if distance is little limited, we can communicate on Bluetooth if you want it wireless. And again, as I told, you can use Wi-Fi, or you have other RF signal, RF this one also, radio frequency can also be used. There are different options. I can make that, yes.
Just tell me your any doubts.
So, to summarize, what we can do is see all this data, whatever it is there, it is coming to this screen. Whatever you are seeing in the screen, you are able to identify whether each and every panel is working or not. So previously, Ajit, you just open the other screen.
Inverter one.
Inverter one, you click on that stream articles. Click on that. Click on that. So, see, to every panel you are able to see how much current is getting generated. Okay, to that level, I can identify there is some problem with the connection with the set of the screens. Somewhere one panel is not connected or not giving me the power or anything. Immediately, the maintenance engineer who is there in the plant is able to know all those things.
For each string, they have connected the temperature sensor also.
Temperature sensor.
For each string, they have connected.
One assembly they will connect.
Yes.
Because if you are connecting all panels, it will
Yeah,
go
that's right.
expensive. Every assembly they will connect one panel. Here we can monitor all strings.
But in the main dashboard, one temperature was there, no? So that is the overall
That is-
site temperature.
Site temperature. That we are getting from the weather monitor. That is individual temperature, what we are mentioning here. That is individual assembly.
Assembly.
Because sometimes the cloud will be there. I mean, inverter one should be on cloud. Inverter two will be a different temperature. That also they should monitor.
Now, in addition to that, we have so many advanced now. We can put a small film type of a thing over the panel. Okay, that also is communicable. You can also see over a period of time the performance of my panel is going to be reduced on it. That can be also monitored. How efficient is my panel can also be monitored. So the previous screen what Ajit had showed, there the customer had asked us that I want all the panels in Velamar. They can clearly see whether it is communicating or not.
Panel-wise data.
Because at level they are able to see.
There we are making one beautiful logic also. Means from morning 9 o'clock to evening 5 o'clock only. This logic will work only. In this time any SMBs go to 0 means it will show red color. I mean they can understand that.
That's the design problem.
Then they will go for SMB immediately they will verify the issue. Then it will come up. Whatever he have mentioned, wherever S is there, that is fair only. That they will not check also.
Because it is there, but it is not being used.
I mean they will using for future.
So what we have done is you are telling about we have done a PSC logic where it will check whether the time is between 8 to 6. Only if it is reached that time, then only it has to raise an alarm. After that time, it should not raise it because in the evening, definitely
It will come, yeah.
all it will come. So that logic we have created. In addition to that, you can also send SMS, you can send a mail, all these things.
There we can send SMS also. I mean, when inverter goes down also, that the customer will get the notification. If any protection something anything operator also, that notification will be get. We are not mentioned here. Okay. Next we will go for the next. I mean, sufficient based one SCADA.
This panel is very good.
created using our eye control SCADA software.
Okay, let's go again.
Ajit, afterwards we'll show sir on screen. We'll show you.
The live screen. Okay, this SCADA solution for only substation based solution only. I mean that is generation station. This is a substation solution. We have full
Transmission substation.
transmission substation only. This is in full and full substation equipment only. They have full and full generation based equipment only. If you are coming to here, if you commonly, if you go to any substation, there are some major components will be there. That major component I compare with our day-to-day life is compare with our home application with the substation equipment also. If you are coming here, this they are called as isolator. Means isolator in our coming to our home application, that is same like a switch. Some switch is there like turn on, that the fan will be run. Like that. If you coming to breaker, is similar to the MCBs are there. MCB, if any fault occurs, that MCB will suddenly trip. If only difference between the isolator and breaker is these are using isolator also we can use and isolate the circuit also. If you are using breaker also we can use isolate the circuit also. But only major difference it will sense any fault also. I mean sometimes it will go for overcurrent. But isolator it can't detect also. It's like a just switch on. If you put on, it will on only. If breaker means it will sense a break. I mean any overcurrent, any abnormal condition will happen means it will detect and it will immediately put the circuit also. I mean this is major using for fault isolation purpose only. This is just for isolation. Next, if you are coming here, we need to here CT is CT means there is a current transformer. It will basically using for measuring the current only. If you are coming to our home application means energy meter will be there. Energy meter only it will read the voltage and current and it will give the electricity bill. But if you are coming to a substation, they are measuring the current, particularly measuring the current, they are using CT. Means current transformer. Next, if you are going, we need to measure same, we need to measure voltage also. That's why they are using PTs. They are called as potential transformer. If you want more detail about CT means, I will tell you, otherwise we will continue.
CTPT people.
Next we will go for transformer. Means we will be using for stepping up the voltage and step down the voltage purpose we are using the transformer. Okay. Just we will understand from here only. Just we are assuming that the feeder number 3 is there. Feeder number 3, that is power coming from the solar power plant. I mean that is VD power plant. Just we are assuming only the power is coming from here. From feeder 4, we are using for this college hall. We in college own generation techniques here. We are using depend upon the TN one solution only. Feeder 4 we are using for our college for college purpose, whatever we are using. Like that way they are calling, this is they are calling as lead, I mean line in, line out. Either here they are generating power, there we are using. Like that way, similar they are called as lead, I mean line in, line out. Like that way, if you are entering the substation, so many concepts will be there. Just for one example, I will tell you. Okay. If you are entering to the one page, I mean, in this way, what and all we are showing that I will tell you. This and all, I mean, that day explanation, how we are doing that this one. Next, here, if you are coming to the indication circuit, here, cable differential operator. I mean, first we should know what is the cable differential. That power already coming from, I told generation techniques VET. From VET to your college is coming. VET to college around, we consider distance is around again 3 kilometers. In this 3 kilometers, any fault or fault something happen means we should get to know. That's why that person they call us cable differential. How it will working means, I mean cable differential means incoming one some current will be there and outgoing also some current will be. We comparing both the current is coming, whatever the incoming current is there, outgoing current is also same, means it will not operate. If incoming current is 50 amps, outgoing current is less than 50 means it will react somewhere current is leakage. We should isolate the system. That's why that cable differential will operate. That breaker will immediately do. This breaker will immediately do. They will isolate the circuit from the fault. This is one example for cable differential. Next, if you are going for tube circuit faulty, I mean tube circuit faulty means any fault occur, that breaker should tube. That's why we should monitor the tube coil healthy also. If you go for breaker means they have closing and tripping coil, both sides will be there. If any fault occur, that tube coil is healthy only, that breaker will trip the circuit. That's why we need to use tube coil tube circuit for faulty also. If faulty means it will indicate vector, if healthy means it will indicate negative. Next, if you fault occur in half phase means it will indicate Y phase, I mean that relay healthy or not, and differential relay healthy, and these are some major important signals from the circuit. This also varies from the one circuit to one circuit. Here we are using cable differential. If you go to another circuit, they are using distance relay. That functionality is different. Sometimes they are using overcurrent electrical players. That functionality will be different. The functionality and design everything differ one circuit to one circuit. This is for one example. Here also is there using overcurrent direct. I mean, this is also direct overcurrent. I mean non-directional overcurrent. Like the way different will be there. So many protection will be there. Just I'm showing some few examples.
So all this protection data is coming from our protection relays. So this relays, how does it communicate? It communicates using RJ45 cable to my gateway. So in that RJ45 cable means it has to communicate in one language. See, the language can be Modbus, language can be IEC 61850. So using that one, we are going to read the data to our gateway. Okay.
Here we are telling how we are communicating on the relays, how we are communicating. This is considered one panel. I mean this panel for only for I think bus stop panel something. There one relay will be there. I mean that relay they call as BCBU 7S or something. That is Siemens relay only. That relay we are connecting to our switch only. It will support 61850. I mean, if you are entering to the substation, we are mostly using 61850 only. That 61850 how it's working, that sir will explain little later. That time we will get to know how the 61850 functioning. Like the way this they are called as IED, I mean intelligent electronic device. These are all the things are IED. Here we are meaning that RSTP communication, that ring and all we are using one ring is there. From one this switch to this switch, this switch to this switch. From here to here, we have made a ring network that they are called as RSTP. Like the way this is they call as networking protocol. If you go for networking protocol, RSTP, PRP, similarly so many protocol will be there. Finally, all data is coming to us here. We are monitoring. Anybody have any doubts?
So basically it is typically a substation architecture which we discussed earlier. Okay. So the devices communicates on different protocols through a Ethernet switch. If it is a network protocol, it will communicate like 61850, it will communicate through a Ethernet switch. Otherwise, if it is a serial communication, we do it on Modbus. Finally, the data is getting gathered within the gateway. From the gateway, we are sending it to the control centers, and you have the local SCADA servers for local maintenance and supervision.
Let's start with the practical.
So, some more information. Communicating the meter. So what we'll see is, we'll just understand how we can read the data from the meter and we can see the data, live data. Practically this is what we are doing in all the substations, or let it be any application for that matter. If you want to read some values, you read the values usually using Modbus. Whenever I am talking about any automation activity, the data will be always, most of the time will be coming in Modbus. From that Modbus, my gateway is able to read the data in Modbus. I'll read data in that gateway and I will show you the meter data is coming. The same thing what we will do is, we can also show it in our SCADA.
Two screen we cannot show us at same time. Okay, first we device to our gateway.
Yeah. So now we are showing that value.
From gateway to
Gateway, you are connected to the switch.
we told to both also same, showing same thing like that. First I show gateway setting, and first I will check. Everything communicated.
Let's check it out.
Wait, so
So I'll just explain what he is doing so that you will understand. See, this is a icon configuration tool. Okay. So this software we need to do, if I have to configure my gateway. So we are connecting this to the gateway. See, what we are doing is, I will just go step by step. We close this. Now the thing is, you just close it and go from the beginning.
okay, start from
See, the thing is, I told you this is a software. Okay, you just need to copy this folder into your system and it will start working. So you go to icon, you open icon and just run on the executable. Okay. Now when you run the executable, what it runs? Now here what it does is, I have an option of I can create a new project or I can download the configuration from my existing device. So let us assume I have not got carried out the backup in my end. So what I can do is when I go to the site, I can load the existing configuration, take a backup, then apply the new configuration. Okay, so
First we explain sir, how we have made set up. How we have made set up.
yeah. What should set up here? So if you see, this is a meter, okay. In this meter, this is a accord meter, and it supports sending data on Modbus protocol. So this has got a RS485 communication port, okay. The RS485 communication port. So here what they have done is, this RS485 to the communication port, we have connected this to the COM port of my gateway. My gateway has got 4 COM ports, okay. To the 4 COM ports, each of these COM ports, a single COM port can support up to 32 devices when we are connected it in a daisy chain, okay. So there are 4 COM ports, means up to 32 meters can be connected to a single device, okay. And whenever I want to say, if I have connected, we connect it in a loop as a daisy chain. So if I have to do it, then I have to set different meter IDs for each of these devices, and then I have to ask from the manufacturer that what is the mapping address of this device. So what the manufacturer gives me is, he gives me a mapping address telling that these are all the addresses on which I am sending the various data. So voltage is coming at, for example, address 101, 100, frequency on 102, like that it gives the address. Accordingly, what I do is, in my gateway, I create a configuration telling that you communicate to this device. When you are communicating to this device, I will go to that device, and here in this case, for example, I connected it to the communication port 3. So I go there and add the meter to the communication port 3. And then I specify what is the meter ID and what is the baud rate, that is at what rate the communication is going to take place. All these parameters I specify in my gateway. Then when I restart when I apply the configuration from my laptop to my gateway, the gateway what it does is it reboots and tries to search for that device from that communication port. Okay, so these where we specify that, okay, that is the configuration of that for that port. We have defined what is the baud rate, what is the parity, all those things, and then what we do is you add a device. You go there and select one, add one device there. Here you go to the COM3 port, click on add. So you can add multiple meters like that. Okay, I can add a device and we can add multiple meters to that, and for that I will define an address. If you see there, the address field is vacant there. I can give the address. That address I would have set it for this meter. Then what happens is, once I apply this one, it will search for that meter with that specified baud rate and it will start communicating. Next, you go to that MFT. Now here, what we have done is from the manufacturer, we have got the Modbus mapping address details from Accord, for example. This is the Accord is the name of the company which is manufacturing the meter. He would have given me the Modbus mapping details. Now seeing that mapping details, he has told me in the address 147, he is sending me the R phase current. Y phase current is 149. Okay, so I specify all those addresses there. Okay, then what happens is it will go and connect to this device and go to the memory of this Accord meter and read those values, and that is fetched to my gateway. Clear? Huh?
Then you're showing online base.
Now the thing is, our gateway also has the provision where after applying the configuration, I don't need to see it in SCADA. I can test it out there itself. I can see the online values, whether my configuration, whatever I have applied, whether it is correct. Okay. Now whatever values Ajit is showing is nothing but the online values which is coming to my gateway from the meter.
For simulating purpose, we are using that way.
Yeah. If I vary it here, you can vary the current.
Sir, I have, so recently some multifunctional meters are available.
Correct.
The multifunctional meters, yes, you said all these parameters are inbuilt, you can watch them. They have given only I2C protocol. I2C. IIC is there. So through IIC they are communicating.
Okay.
Whether this will connect with IIC to connect.
IEC means IEC we have 101, 104.
Yeah, correct.
You have to tell, we can do that. See all these things, that is what I am trying to tell you. What we can do is, this communicates on 61850, whereas this communicates on Modbus. There might be one more relay. Okay, there is a production relay which communicates on IEC 103. 103. So what happens is, we read for that also, I will refer the manual of that particular manufacturer. He would have told me what are the addresses at which that data is going to be sent. For that, I need to have an understanding about that protocol, how it works. Basically, protocol is nothing but a language which we use to communicate. Each one has got its own standards. So we have to follow those standards and configure the respective properties in this gateway so that it is able to send a request to the respective device. Okay, then after receiving the request, it is going to give a response that will be again understood by the gateway. So this is nothing but it is like that is why it is called as a data concentrator. It is able to communicate using multiple protocols. Okay.
Currently, we are connecting only office voltage only.
No, it's changed to 8.4. Before it was 4.448, now it changed to 8.4.
Change again.
Downgrade one, do not.
So it has now become 4. This one. It changed now. So it is again come back to 8. So we have got that variac where we wanted to show you that the values can be changed.
And so 104 test also, sir.
Okay.
Now we are this kind, same data we are sending to 104.
Basically what he is trying to tell you is, now this data we are receiving it here. Now let us assume I want to send it to load dispatch center. Then if I want to send it to a load dispatch center, I need to have a communication medium. It can be communication medium, I can send the data through a modem. If I connect this gateway to a modem, it will send the data to the load dispatch center, or it can be a VSAT modem. It can be different types of communication. So when I am sending the data, I will be, for example, what he is trying to do now is, he is trying to send this data in 104, and then he will try to receive this data in 104 locally by using a 104 tester, IEC 104 tester. The same meter data, we will receive it in 104 and show you as though we are receiving it at control center. So this is how SLDC will be receiving data. Okay, so we are using 104 tester. So when these people, I told you now, the utility people will come to our factory and see whether this is working. So we show it using a tester. See, the data is coming from my gateway. We are receiving the data from the meter here, and we are receiving it in a 104 tester. Okay, these are the different addresses on which it is communicating.
The same address you are defining in gateway.
So what we usually do is, here I am sending the data. Okay, when I am sending the data, I can decide on what address I have to send. Usually what they do is, this address is given by my SLDC team. Say for example, the SLDC team which is there in KPTCL head office, they tell me, for this substation, you need to send all this data in these addresses. Accordingly, we map it here. Okay, and now the data, we will take the confirmation from them whether they are receiving the data. Thing is there like that. Make sure that we'll do one thing. What I will do is, I told you that we'll show our cloud application, and we will also show the application which we have installed at the customer site. So that application, we are going to see the live data which we have installed there. First connect me. So here what we have done is, this application is being installed at the customer site. Okay, this is a site which is there in Udupi. Okay, where it's an hydroelectric power generation plant, where the data is being, that application is there locally, and it is being, we have deployed it on the internet. Okay, so at any point of time, from anywhere, they can monitor this substation. Now you can observe here, they are able to see there are totally 8 meters which are connected. There are 2 sites there. One is called as the generation site. This is called as a plant site. Okay, in the plant site, they have these devices which are connected. Okay, and all the data, we can, the user at any point of time can check whether it is communicating or not. Okay. Now, these are the meters which are connected there. Okay, so usually they have, as per the utility norms, you should have 2 meters. One is called as the main meter, other is called as a check meter. So I will just explain you the architecture here. Now, what is happening is, we have connected this gateway similar to this. That gateway is being connected to these meters. Okay, and this gateway in turn is being connected to a modem. Okay, that modem is sending the data to my application server. My application server is reading that data on which we have developed this application, and we have exposed it to the internet. Okay, so that they are able to see the application both on their mobile as well as they can also view it on the laptop from anywhere. Now at this point of time, you can see the current values of there. In addition to that, they can generate the reports. All these things are there. Okay.
It's a current data. If I want to take the last year data, so
Yeah,
it will be stored in the
Yeah, it will be there.
It is not downloaded.
Again, next to go to the other one. So this is a dashboard, okay, where they can see that information is come down.
So when meter is communicating, it will be shown in green color. When it is not communicating, it will show. When this line is off or something, it will show in red color.
No, at present that particular this one is down. That is why it is showing as red.
The 8 meters are up. So only this are also.
You can show our application which is there on cloud. Now this whatever we are currently showing, see in our factory we have connected the meters, okay, and that meters we have connected is being connected to the gateway similarly. There we have kept one modem, okay, that modem is sending the data in MQTT to the Amazon cloud. Okay, in the Amazon cloud we have deployed the same application. Okay, so there we have created one MQTT client which is receiving data from an MQTT broker, and that data is getting displayed. Okay, this is called as this is for our automatic meter reading customers. So what I told you in Karnataka, we have implemented around 450 sites where our gateway is sending the data to the SLDC. In addition to that, our gateway has got one more port. It has got 2 Ethernet ports. We have connected the another Ethernet port. We can connect it to a modem, and that modem, through the modem, I am sending the data to my cloud server. So how is the data going? My gateway also supports MQTT. In the upstream, I am sending data in MQTT, and that data is being received on the AWS cloud, and I give, similar to this, I give my login to all my generators. The generators can view the respective information about how the generation is taking place. Okay, so it is called as a automatic meter reading monitoring system. Okay.
These data are plant data.
Yeah, it is plant generation. The generation actually thing. Okay, we are still working on developing the reports and all, wherein I can generate the reports automatically. Like whenever I talk about this automatic meter reading, we communicate on a protocol called DLMS. Okay, we can communicate on a protocol called DLMS, where we have two options. One is reading the instantaneous values. Okay, and the second option is we can also download what is called as a metering profiles. We can download the profiles. Say we call it as a load survey profile. Load survey profile gives me 15 minute at every 15-minute interval what is the current voltage, frequency, active power, reactive power, all those things comes in that load survey file. Then you also have got different profiles are there like midnight profile and all. Those files gets automatically downloaded to my gateway. It gets automatically downloaded to my gateway, and that files actually I am pushing it to the database server at SLDC. There they push that data, that CSV files to their Oracle database, and based on that data they are generating the billing. Okay, like how much power it is getting generated. Based on that, the revenue, whatever power they are generated, for that they are getting the payments. Now, some people what they do is they generate the power and they may use it somewhere in their factory. So they minus that generation minus consumption, and the remaining thing gets billed. Okay, so we have one is SCADA, another one is we have. So this is a CSV file. Okay, this CSV file in turn what it does is it gets downloaded from the DLMS meters to my system, and then it pushes it because it has also got a secure FTP server here. Through FTP, a secure FTP client, I push it to my FTP server. Okay, it can and what I can do is I can in our case we are sending it both to KPTCL, and it can also come to our AWS cloud. Okay, this cloud application we are giving it to the customers. For KPTCL, it is going through the another port to KPTCL. So it is serving both the customer as well as this one. Now the customer has got a choice. When they finally bill to this generator, this is what you have generated, they can always cross check with their report whether the generation is matching with the utility side report. Okay. If you have any doubts, you can ask me. This is just an overview I tried to give you. Thank you everybody. Thanks for your attention.
So thank you so much for your insightful session. If you have any question, you can ask us. Well, actually, one I have. So, what does that I stands for? Whether it is intelligent or internet?
Which one?
That I grid, right? Any specific thing that I stands for?
It is for internet only.
Internet. Thank you so much, sir. So.
Thank you so much, sir. So the session was actually, as I told you, it's all completely new to us. So many of the things we learned, and you see that how best we can take it to our students. Maybe, as you said, some of our alumni is also working there, and maybe we'll try to contact them. So we can train the existing students so that maybe some of other people also get that.
As I told, what we can do is there is a huge demand for substation automation engineers. See, you cannot generate substation automation engineers directly. They have to work and they have to do it. But what we can do is we can inculcate all these things by having a small automation panel type of a thing. And we have a breaker, all those things, and so that can be tested by the engineering students. And it can have a small program type of a thing where 1 month to 1.5 months as a before in 7th or 8th sem, wherein they can do that, which will help them a lot. Okay.
So sure, sir, we'll take it forward and see how best we can use it for our students.
I kindly request Dr. Prem Kumar sir to hand over the memento and LOA to us.
Thank you so much.
Thanks for your patient listening. Okay. I will leave the card with sir. If you have any queries or anything, you can reach me on my mail or the mobile. Okay.
So we'll take one.
Call Kiran sir.
Space not be required, you just call and ask them to do this arrangements.
Yes, yes, but we had a couple of conversations back then, but then they was not
The space may not be sufficient, so we'll take it out. What to be here, where you people are going, I don't know. Just take out this table and organize it with chairs. Sir.
One more second, because crowd is more full.
No, so people can stand so that we can cover more. This you can take it out. Tripod to take it.